Hello everyone, welcome back to my channel, Biostatistics Insight. Today we are going to discuss what is spline regression. We will cover the topic how to use, where to use and how to construct spline regressions. So let's start here. First we are going to know what is the regression. So regression or linear regression is the analysis where we are able to understand the relationship between dependent and independent variable with the help of fitting the straight line through the data points. Okay, when the linear relationship does not exist at that time, polynomial model will come into the picture. Yeah, so understanding spline regression. Spline regression comes when first one is linear regressions. Fit a straight line through the data points to understand the relationship between dependent and independent variable. Polynomial, when data are not follow a straight lines, then polynomial will come. In spline regression, when it in the spline regression we use the pieces wise polynomial, or you can say we can create it at interval to construct a model in a complex relationships. Okay, so now what is spline regressions? Spline regression is a special function defined piecewise by polynomial where the term spline is referred to as class of the function that used to applications requiring data points or smoothing. The data may be either one-dimensional or multi-dimensional. So when the linear relationship does not met and your data point does not follow a specific pattern, we will come up with the spline regression. Spline regression is a one of the non-parametric approach in a regression technique. In this technique, the data set into divided into bins or intervals, which we called as knots. That's called as knot here. Also, the bins has a separated fit. Now, spline regression. Spline regression's features. First one, piecewise function where we divided into data into the bins. So it is a piecewise functions. Knots, points where adjacent polynomial meet, ensuring connectivity or smoothness. Polynomial degree, it is a typically linear or quadratic or cubical relationship. Flexibility. Flexibility means when the non-linear relationship we can able to trace it. For example, in this case study where blood pressure and cardiovascular, we have a treatment group standard, intensive and standard, baseline BP and 6-month BP also there. The baseline is 140 and after 6 months it is 130 and the cardiovascular event happens no. So we have a data of 200 patients evaluated the effect of BP reduction to the CV, cardiovascular risk. So spline regression analysis first goal, model the relationship between blood pressure reduction and cardiovascular event rate. So it's clearly mentioned here that cardiovascular event rate is directly proportional to blood pressure reduction. And we are taking 3 knots here, 5, 10 and 15. In the 3 knots we are calculated cardiovascular event rate with the percentage and we'll see that it is coming to the reduction point but not in a similar way. The 5 when we have a 5 knot we can see it is a 19% reduction in cardiovascular event rate, but when the knot is 10 then the event rate is 40% reduction. So interpretation, the spline regression model estimate the relationship between blood pressure reduction and cardiovascular event rate. Key findings here. First, blood pressure reduction is associated with decreased cardiovascular event rate. The second one, the relationship is non-linear because it's not following any trend or pattern with greater reduction in CV event rate at higher blood pressure reduction. The model estimate a 40% reduction. See, 40% reduction in event rate for a 10 mm Hg blood pressure reduction. Now, what is the clinical implications that we are going to remember here? First one, intensive BP lowering the effective in reducing CV, cardiovascular risk. The target blood pressure level should be re-evaluated based on the individual patient risk profile. We have to re-evaluate it with the individual patient or a subject risk profile. That would be the another further process or further steps that we have to follow. Now, this is the graph that we are creating through the library ggplot, and this is the code that you can use it. Now, what is the advantage and limitations here? First one, flexibility. It provides you to find the relationship between complex model. Non-linear handling, when the data does not follow a linearity, then we can able to trace it non-linear linearity with the help of splines. Interpretation, it provide a better way to understand the complex informations. Limitation, because we are creating knots here, so the selection of knot and risk of overfitting will be the limitations here. Now, applications, yeah, that's very important here. First one, when the studies are dose finding studies. So dose finding is means determining the optimal drug doses for the efficacy or safety. If we wanted to know the maximum tolerance limit, so we can use this spline regression. For the longitudinal data analysis, when we have a data with the repeated measure ANOVA, where we have a data over the subject visit, with a multiple visit actually. So at that time we can use it. Time to event analysis, yeah, in the survival analysis, where we need to construct the model based on the survival rate and disease progression, overall survival, progression survival over the time, we can use it. Subgroup analysis, when you wanted to see any effect of the subgroup or any other effect that provided in the subgroup, that we can assess it through this spline regression. Now, how to construct spline regression in R? First we have to load the libraries, that's known as splines. Second, generate the data. Third, fit the model. Fourth, visualize the result. So there is a first step. You have to, this is known as your R Studio, where you need to install the library that's called splines. With the help of the step, I added these steps also, so you can follow it and try it your own basis. First one, install packages splines. Second one, generate sample data, that we are trying to generate a dummy data where x and y variables here, x sequence and y. Now, then fit a spline regression model. With the help of LM and NS, we are creating a spline regression model where NS is the spline packages to use to create a natural spline basis of 4 degrees of freedom, where DF is 4 here. You can see the if there is any error or there, so you can see in this console window. Now, visualize the result. If we want to visualize, so we have to use the statement plot with the x and y values, where lines predicts the x, and we can add it the legend also. That here I added legend is top right, and this is called as the inside result also. Legend is fitted spline and column is red. I put it as red here. So this is with the help of this code, you are able to see the spline regression plot. So this is the x-axis values and y-axis values. Now examine residuals. Checking residuals help assess the model's goodness of fit. Examine residual spline regression. So with the help of this, you can see or assess the residuals. Plot X residual mean, where in the main we are going to predict residuals of a spline regression, and X lab is in X values and Y lab is the residuals values. So here the overview of the spline regressions. Okay, thank you so much. If you have any questions, please do comment in the section at that time. Thank you so much and happy Diwali.